array implementation of circular queue. Data structures using C. In this lecture, we will deal with the array implementation of circular queue. As you remember, in the last lecture, we have done array implementation of a queue. But there is a problem in that. We will deal with that immediately. So what are you going to do? We are going to learn how to implement circular queue using an array. And secondly, write functions enq and deq, similar functions we have written earlier, to input data items and delete a data item from a queue. A little complicated than the earlier one. And I had simplified the queue structure by copying. After deleting, what we did was at the end we copied all the numbers starting from the first to the last. That is what we do, and there was no problem as regards empty queue still being considered as full. For example, here take this example. As you see here, there is 30 and the rear is pointing to 4 and front is also pointing to 4, and you see this is blank here, there are no numbers here. But when you want to input one number, rear is going to be 5, and immediately you will get a message saying that the queue is full, but factually it is not full. To circumvent that, what we are going to do is we are going to implement queue structure using circular queue. Now, circular queue is also same array, but the algorithm is slightly different. So what we do is, in case now we want to, in this case, I want to add one more number. Naturally, rear has to become 0, and then I add the number. Then I go on like this. And only when the number comes here, and this is rear and this is going to be front, then we say that the queue is full. So let us work at it now. So now about implementation. Here we have the declaration of a new data type called queue. As you see here, it also contains an array of the size here 5 we have given, and there is a front and rear indices are there, and we are including one more variable called capacity to tell us exactly how many numbers are there. So this becomes therefore queue. I have named it as circular queue type, then queue, and I am declaring a variable called queue which we are going to use in all these functions. Therefore, this queue is going to be a global variable accessed by all these functions which will be declared after the main. Now init queue. What are we going to init in the init queue? Init queue, I am initializing the front and the rear to -1. Therefore, if front and the rear is equal to -1, we know that the queue is empty. Or even if the rear of the queue is -1, we know that it is empty. And therefore we say capacity is equal to 0. This is the small function we are going to write to initialize the queue. So we initially have to say that it does not contain anything. Therefore front and rear are -1 and capacity is 0. So of course this is the function menu which you are very familiar with. Now let us come to adding a number to the queue. As you see here, we have a circular queue. So of course, it is array, but we are representing it as circular. So this is the front here index and the rear index. So there are three numbers are there. Three numbers are the front. And as you know, in a queue, so first in, first out, FIFO, FIFO, first in, first out. So deletion is done at the front and addition is done at the rear. Therefore, the next number, where is it going? So to next number will go naturally. Now index, rear index is 3. So therefore, it has to be incremented to 4 and the number is inserted there. So this is, it's a very simple idea as we have done earlier. But there are some cases. They will get into these cases now. There are 4 different cases to find out. For example, when here 35, I want to increment. So if 4 becomes 5, but I want it to be 0. So how am I going to do? So for that we are using a special algorithm. So if we, so whole algorithm is increment rear and then insert the number. That's all. But after incrementing the rear, I have to find out the index, next index, and that is done using this way. That is, always what I do is I find the modulus. So rear, you take the rear, and modulus size is 5. For example, take it. So rear is equal to 0. So 1 modulus 5 is equal to 1, 2 modulus 5 is equal to 2, etc. 4 modulus 5 is equal to 4. When it comes to 5 modulus 5, it becomes 0. So that is a very good thing, as you say. So this is incremented to 5. Then 5 modulus 5, 5 will give us 0. So therefore, then it goes on like that, incremented, etc. So this is a better way of finding out the next index of my rear or next value of the rear. So we are going to use it on all our functions. So let us see now. We'll take some cases as you see here. 1, 2, 3, 4. So case 1 is Q is empty. That means rear and front are equal to -1. So then what do I do? Then I say front and rear is equal to 0. Then simple, so they becomes both of them are pointing to the 0th cell, and we insert the number. This very simple. Insert the number there. This is case 1. That is my circular Q is empty. Then I initialize front to 0, rear to 0, and then insert the number at the rear position. That means it will go to the front and rear. What is? Let us take case number 2. Case number 2 here, as you see, this circular queue is full. Now I want to add one more number. Naturally, the rear value is going to be, of course, in this case, since I say rear becomes 5, 5 modulus size, that is, it becomes 0. 5, so it is going to 0. But then what happens? Then I ask this question: if rear equal to 0 and front is also equal to 0, and if Q is full, how do you, the Q is full, that is capacity is equal to size, then of course I immediately give a message saying that it is full, therefore decrement the value of rear, decrement the value of rear. This is case 2. In case the Q, circular Q is full, completely full, then I go back, I say rear is equal to size minus 1. So size is, as you know, it is 5 here. 5 minus 1 is equal to 4. So real will go back to this place. Okay. Now let us see. So it becomes there as you see here. So we will take case number 3. So rear and front point to the same index and Q is full. So now for example here, now rear is equal to, now rear is equal to 1, front is equal to 2, it is full again, it is full. So what happens in this case? Rear becomes rear plus 1, 2. So both of them are equal, front is equal to rear. Then again I decrement the index rear by 1. Again I go back. So I brought it to 2. I am going back to 1 to keep, say that the rear is, index is 1 and the Q is full. That is a message I am going to pass. What is the fourth case? In any other position, for example, here 1, 2, 3, front is at 30. So I need to add the next number. So you increment the rear to 4. So rear becomes 4, and you insert the number at the fourth position. So that is the case number 4. So all these things are put together in this function now, and here is the flow chart for that. I would like you to note down this flow chart. If rear is equal to -1 and front is equal to -1, naturally, as I said, you initialize both of them to 0 and then insert this number at the rear. Always the inserting of number is done at the rear. Otherwise, what happens? Otherwise, what you do is, in this case, as you see, so you increment the rear and find the next position. We are using this formula, rear modulus size. Now, if the capacity is equal to size, that means if the this thing is full, you ask them question to find out whether rear is equal to and rear and front are 0. If that is 0, as I said, showed there, you decrement the rear by 1. Size -1 becomes rear. Then if it is uh, or if this is not the case, it may be both of them are equal, pointing to some other place, as I've shown you earlier. So then what? Then also you have to decrement the rear -1. So then you give the message that it is full and you come out. So you cannot insert. Now this is the case when the circular queue is full. Therefore, we only what we do is we go back to the original value of rear. So that is what is done here in both the cases, and then we give the message that queue is full. Otherwise, what happens? Otherwise is a very simple case, as I've given case number 4, and therefore you insert that number at the rear. So this is case number 1, case number 2, case number 3, case number 4. All this is there in this flow chart. Therefore, I would like all of you to pause this video and write the complete function called NQ. Let us see. We'll take some example here. So here size is equal to 5. So first is pointing to, both of them are pointing to 0. So I am inserting 70. Now I increment the value of rear. I want to insert next number 30. Again I increment the value of rear. I insert 60. Now I am deleting this thing. Always deletion is from front. Therefore front value is incremented to 1. So now what do I do? Again I am incrementing the rear and inserting 80. Again I am incrementing the rear and inserting 45. Now I want to increment the rear. As you see, it becomes 5 here. Rear becomes 5. 5 modulus 5 is equal to 0. So it is rear is going to be 0. I have incremented and inserted. Now if I go ahead now, it is going to tell us rear value is going to be 1, front is going to be 1, and we are going to give the message saying that the queue is full. Queue is full. So here is the complete function void NQ int number. First case 1 here. If both of them are pointing to -1, I initialize them to 0 and insert the number at Q rear, and I say capacity is 1 because it was nil earlier. Now the capacity is 1. Otherwise always I increment, I use this formula to find out the real value of rear, and then of course this is for you to help to debug the program. Then if the capacity is equal to size, that means it is full. There are two possible, case 2 and case 3 here. That means both of them are pointing to 0. Then as I said, do decrement the value of rear, size -1. It becomes, in this case, it becomes 4. it was pointing to 0. Now 5 minus 1 is going to be 4. But both of them are equal in another position. Then you decrement the value of rear by 1. Suppose both of them are 3, 3. Then front is pointing to 3, rear is pointing to 3. Therefore, rear has to be 2. Rear has to be 2. So this is what you are going to do, and this is the case when the queue is full and you say queue is full and come out. Otherwise what you do? Otherwise you insert the number at rear and increment the value of capacity, and then you of course this is what you have to do and come out. That is the function to insert a number into a queue. So let us see now one more example here. So both of them are pointing to 0. I insert 20, then point to rear becomes incremented to 1. I insert 30, and here rear becomes 2. I insert 60, rear becomes 3. I insert 80, rear becomes 4. I rear insert 45, and I'm deleting the, so this is front becomes 1. So again I am inserting value because rear has become 0 now, inserting. Now if I try, rear is going to be 1, front is 1, and it is going to give us therefore equal to that the circular queue is full. So this formula is very important. Rear is equal to rear modulus size, so as we have shown here. Now deleting number from the queue. And deleting the number is done always from the front of the queue. So for example here we have got one case. In this case what we do, first I get the number from the front, queue front. For example here queue front is pointing to 2. I want to delete, therefore I am going to copy this number to this variable called number. Then I increment the value of front to 3. It was 2, now it has become 3. And you decrement the value of capacity. Capacity was 3 earlier, now it becomes 2. So this is to be done in the case of deleting a number from the queue. And as I said, always it is deletion from the front of the queue. So this is the algorithm. This is the algorithm. If capacity is equal to 0, then you immediately say the queue is empty, nothing to delete, and you come out. Otherwise what you do, you get the number at the front of the queue and decrement the value of capacity and increment the value of front, because you have deleted one, you have to increment the. Now one more thing, if it becomes size equal to size, that is front index is reached the end, that means it is going to when you increment it, suppose for example our size is 5, the last index is 4, now it has become 5. Therefore what you say, if it is equal to, then immediately you say front is equal to 0, front is equal to 0, and return the number. So this is what you are going to do. We will check the, yeah. So as you see here, if capacity is equal to 0, immediately you say queue is empty, you come out. Otherwise what happens? Otherwise take the number, for example here, you take the front here, 30, and then use capacity, you decrement the value. There are 4 numbers, capacity becomes 3, and you increment the value of front to 2. Yeah, that is the thing. Now in this case, let us say, so here front is equal to 4, front is equal to 4. So you have removed that 30. Now front is equal to 5, it becomes 0 here. It becomes 5. So here front is become 5. So if front is become 5 is the size of this uh, circular queue. So if it becomes 5, you initialize front to 0 because it has gone there. Front has to point to 0. That is what is done. You can also use that formula also to do that. You need not ask this question, but to be much more clearer, I have used if front is equal to 0. So here after deleting 30, front becomes 5. When you increment that, so immediately, so front is equal to 5, you make it 0 because it has to point to the 0th position in my circular queue. So this is, now you write your whole function. So for example, dq, if it is capacity is 0, immediately you say is empty, and you initialize the queue. Very important. Both of them have to be initialized to -1 -1. That you should not forget. And then if it is not, what is that, this thing empty, then you remove that number from the front of the queue, decrement the capacity, and then this is what you do is if front is equal to size, you initialize front is equal to 0 and return the number. So now last thing is to print the content of the queue. So printing is always from the front till the rear, front to the rear. So I first, for example, front is equal to 4 here, then it has to be 0, 1, 2. So this is how we are going to print. So again we are going to use the same formula. So as you see front here, then front is equal to front uh, modulus 5. So 5 becomes 0, 1, 2, 3. So naturally it is going to print 30, 55, 60, 70. So here this is the algorithm, or this is the program to print the content of the circular queue. So capacity is 0, naturally will come out, nothing to print. Otherwise get the value of front in I, is assign it to T, and T is equal to I modulus size. So then you have, as I showed you earlier, so this is going, it is going to give these values. This is going to give these values automatically one after the other. Therefore, you print from T is equal to value where it is 0, and then as long as T is not equal to rear, you start from the front till you come to the rear. You print the values present in the circular queue. So this is what you are going to do, and this is again I have shown you earlier. This is init queue. So now I would like to put all these programs together, so these functions together, and write a menu-driven program to show the working of a circular queue. Working of a circular queue. That is what you are going to do. So here I've got, for example, choice 1, 1. I entered 60. So front is, this is of course after entering 4 numbers. Already there are 4 numbers. The capacity is 4. Capacity is 4. And here, so enter 3. As you see, there are 4 numbers, 1, 2, 3, 4. T is equal to 0, 1, 2, 3. So what do I do now? So in this case, uh, uh, so we have deleted one number here. So again enter choice 3. After here again we have deleted number here. For example, delete the number 2. So capacity has become 3. 20 has been deleted, and I want to, so front is equal to 1, rear is equal to 3. I am printing the values of 30, 40, 60, 30, 40, 60. These are printed. So this is how you are going to implement the circular queue.